Hello, I'm Alan Bowling from the Department of Mechanical and Aerospace Engineering at the University of Texas at Arlington. This is the second part of Systems of Equations and Matrices in Engineering. So let's get started. Okay, in part one, we were looking at this problem of flying from this point over all the buildings and flying to this point over here, while one of our friends was going to fly starting from this point. They're going to fly over all the buildings and fly over to here. And there's this point in the middle where we might have a collision, and we wanted to find out what that point was. So here we're going to do the math involved in dealing with that. So let's move on. So we did this problem by, instead of using 2D vectors, we developed an equation of a line that would describe motion starting at this point and moving to that point, moving in that direction to the point B, and motion at starting from point D and moving along the line in that direction to get to point C. And we found these two equations to describe those lines. So now let's try to solve them and see if we can find this point right here. So one way to solve this system of equations, and our system of equations is this, and then it's this. So we can solve this by first eliminating variables. And conveniently, we have this equation here, which already gives us x solved in terms of y. So we can just take this, we can substitute this value for x, or this value for y, substitute it in there, and we will get this equation. X is equal to minus 3 over 4 x plus 4. And we can solve this by subtracting this term, of course, from both sides. So we'll get x plus 3/4 x equals 4. And then we add them together. And if you want to add fractions, you're going to get 7 over 4 x is equal to 4 is equal to 4. And now we multiply both sides by the reciprocal of this, and we get that x is equal to 4 over 7 times 4, which is equal to 16 over 7. That's x. And now that we have x, now we have x solution, we can take this x and plug that back into here so that we get y is equal to 16 over 7. And that is our answer. So we're going to collide at the point we have the possibility of colliding at this point on the map. Okay? So let's look at a different way to do this. Okay, let's try to solve our system of equations in a different way. So here's our system, and we're going to solve it using matrix algebra. So the first thing we got to do is put all of our variables on one side. So in end up with, and then we're going to put them in matrix form, which involves taking out all the coefficients. So you get this, you get 1/3 times x, y equals 0/4. Now in matrix algebra, we know that this matrix here, we're just going to invert it, and if we find its inverse and multiply that inverse by both sides, we will isolate x and y so we can solve for them. So the first thing we need to have is the matrix inverse. And because this is a very simple matrix, we can write the inverse in a very simple way. And we say this -1. That -1 indicates that it's the inverse. And that is going to be equal to 1/AD minus BC. And then you swap some of the components around, and it comes out like that. So if we apply this formula to our matrix, so if we apply this to that, we get this 1 minus 1. The inverse is going to be equal to 1/A times D, which is 3/4. That's B times C is -1 with another minus, so it looks like that. And then we have to swap these components around. So you get that, and then we negate the off-diagonal ones so that you get that. And if we work through this fraction, you'll end up with 4/7 times 3/4, 1 minus 1, 1. And that will end up giving you 3/7 times 4/7 minus 4/7, 4/7. And that is our inverse. So if we multiply this guy, that's our inverse. So we're going to multiply it here, and we're going to multiply it in front here. So this, when we multiply it out front here, this guy will become identity. And it's going to look like this. 1, 0, 0, 1. That's the identity matrix. And you get that. And now we got to multiply the other side. 3/7, 4/7 minus 4/7 over 4/7. And that's going to be times 0/4. And if you multiply that out, it's this times this, plus this times this, which gives you 16/7. And then you multiply this times this, and this times that, gives you another 16/7. And if you multiply these two guys out, you'll get x over y. So when you compare these two, you see that you get, your result is that x equals 16/7 and y equals 16/7. And that is the same answer we got using elimination on the earlier slide. Okay, so that tells us that if our starting point is here is 0, 0, then our collision will happen at 16/7, 16/7. So in summary, we learned how to describe a real-world problem in terms of a system of equations. We solved this system using two different approaches, elimination and matrix inversion. And using that, we were able to find out where our mid-air collision with our friend might occur. Thank you for watching.